everybody, this is Mahalakshmi K. Today I would like to discuss about the networking analysis under PERT method. PERT is a networking technique used to determine the expected time for completion of activities involved in a project. There is one problem. The following table gives the optimistic, most likely and pessimistic time estimates for the activities of a project. Below that there is one table. In that activity, optimistic time, most likely time and pessimistic times are given. For activity 1 to 2, the optimistic time is 1, most likely time is 3 and pessimistic time is 5. For activity 1 to 3, optimistic time 2, most likely time 4 and pessimistic time is 12. For activity 2 to 4, optimistic time is 3, most likely time is 5 and pessimistic time is 7. For activity 3 to 4, optimistic time is 4, most likely time is 6 and pessimistic time is 14. For activity 3 to 5, optimistic time is 2, most likely time is 5 and pessimistic time is 8. For activity 4 to 6, optimistic time is 5, most likely time is 7 and pessimistic time is 9. For activity 5 to 6, optimistic time is 4, most likely time is 6 and pessimistic time is 8. For activity 6 to 7, optimistic time is 3, most likely time is 4 and pessimistic time is 11. You are required to, point number A, calculate the expected time and standard deviation of the activity. Point number B, draw the PERT network diagram and determine the critical path. Point number C, calculate the Z value and determine the probability of the completing the project within 20 days. This is the problem. Let me move to the solution. In a solution, point number A, calculation of expected time and standard deviation. In a problem, the activities optimistic time, most likely time and pessimistic times are given. Now we calculate the expected time and standard deviation. For calculation of expected time, there is a formula, that is expected time is equal to optimistic time plus 4 most likely time plus pessimistic time divided by 6. This is the formula for expected time. For activity 1 to 2, expected time is first optimistic time is 1 plus 4 into most likely time is 3 plus 5 divided by 6. 1 plus 4 into 3, 12 plus 5 divided by 6. 1 plus 12, 13. 13 plus 5 is 18. 18 divided by 6 is equal to 3. This is the expected time for the activity 1 to 2. 3. For activity 2, optimistic time is 2 plus 4 into most likely time is 4 plus pessimistic time is 12 divided by 6 is equal to 2 plus 4 into 4, 16 plus 12 divided by 6. 2 plus 16 is 18. 18 plus 12 is 30. 30 divided by 6 is equal to 5. As like that, for activity 2 to 4, the expected time is 5. Activity 3 to 4, the expected time is 7. For activity 3 to 5, the expected time is again 5. The activity 4 to 6, expected time is 7. The activity 5 to 6, expected time is 6. The activity 6 to 7, expected time is 5. Now we calculate the standard deviation of the activity. For calculation of standard deviation, there is a formula. Sigma square is equal to pessimistic time minus optimistic time divided by 6 whole square. For activity 1 to 2, pessimistic time is 5, optimistic time is 1 divided by 6 whole square equal to 5 minus 1 is 4 divided by 6 whole square. 4 divided by 6 is equal to 0.67. 0.67 square is equal to 0.67 into 0.67 is 0.44. For activity 1 to 2, standard deviation is 0.44. For activity 1 to 3, pessimistic time is 12 minus optimistic time is 2 divided by 6 whole square. 12 minus 2 is 10 divided by 6 whole square. 10 divided by 6 is equal to 1.67 square into 2.78. The standard deviation for 1 to 3 is 2.78. As like that, for activity 2 to 4, the standard deviation is 0.44. For 3 to 4, 2.78. For 3 to 5, 1. For 4 to 6, 0.44. For 5 to 6, 0.44. For 6 to 7, 1.79. This is the calculation of expected time and standard deviation of each activity. Next, point B is draw a network diagram and find out the critical path. Based on the expected time, we draw the networking diagram. First, 1 to 2. The activity 1 is 1 to 2. So, I take 1 here and 2 here. Next activity is 1 to 3. So, 1 to 3. Next activity is 2 to 4. So, I take it like this. 2 to 4. Next activity is 3 to 4. So, I take it like this. 3 to 4. Next activity is 3 to 5. 3 to 5. Next activity is 4 to 6. 4 to 6. Next activity is 5 to 6. And next activity is 6 to 7. The expected time for 1 to 2, activity 1 to 2 is 3. For activity 1 to 3 is 5. For activity 2 to 4 is 5. For activity 3 to 4 is 7. For activity 3 to 5 is 5. For activity 4 to 6 is 7. For activity 5 to 6 is 6. For activity 6 to 7 is 5. This is the PERT networking diagram. Next, we find out the critical path. For reach the destination, we go with 3 routes. For example, 1 to 2, 2 to 4, 4 to 6, and 6 to 7. This is the one way. And another way, 1 to 3, 3 to 5, 5 to 6, 6 to 7. This is second way. And third way is 1 to 3, 3 to 4, 4 to 6, and 6 to 7. For these ways, time is 1 to 2 is 3, 3. For 2 to 4 is 5. For 4 to 6 is 7. For 6 to 7 is 5. For second route, 1 to 3 is 5, plus 3 to 5 is 5, plus 5 to 6 is 6, plus 6 to 7 is 5. For third route, 1 to 3 is 5, plus 3 to 4 is 7, plus 4 to 6 is 7, plus 5 to 6 to 7 is 5. 3 to 5 is 8, 3 plus 5 is 8, 8 plus 7 is 15, 15 plus 5 is 20. Next, 5 plus 5 10, 10 plus 6 16, 16 plus 5 21. 5 plus 7 is 12, 12 plus 7 is 19, 19 plus 5 is 24. In these 3 routes, the highest time taken route is third one, 24. So that the third way is the critical path in the networking diagram. Means 1 to 3, 3 to 4, 4 to 6, and 6 to 7. This is the critical path in the networking diagram. Total expected time of the project is 24 days. Now we calculate the standard deviation of the project. So the route 1 to 3, 3 to 4, 4 to 6, 6 to 7. For the route, the standard deviation is for 1 to 3 is 2.78 plus 3 to 4 is 2.78. 4 to 6 is 0.44 plus 6 to 7 is 1.79. The uh, total is 7.79. This is the variance. The standard deviation is 2.79. The total standard deviation of the project is 2.79. Point number C is calculation of Z value and probability of completing the project within 20 days. For calculation of Z value, there is one formula. Z equals to stipulated time minus expected time of the project divided by standard deviation. The stipulated time is already given in a problem, that is 20 days, minus the expected time of the project is 24 days, divided by standard deviation of the project is 2.79. 20 minus 24 is minus 4, divided by 2.79. Answer is minus 1.43. The Z value is minus 1.43. We neglect the minus symbol, and in a cumulative normal distribution table, the stimulated time for the completing the project is the chance of 0.92 or 92% of the chance for completing the project within a 20 days. This is all about a simple problem under the PERT method.